Hi, my name is Takuzo Ganre. I'm a former A-level student and I graduated high school with straight A stars, and I'm here to help you do the same, or if not, just to make A-level maths a little less challenging for you. So in this video, we'll be focusing on how to find the equation of a circle. This topic falls under coordinate geometry, and we'll be focusing on the following syllabus points. Understand that the equation x minus a squared plus y minus b squared equals r squared represents the circle with center AB and radius r. Use the expanded form x squared plus y squared plus 2gx plus 2fy plus c equals 0. Use algebraic methods to solve problems involving lines and circles. Please note that knowledge of geometrical properties of a circle, such as circle theorems, is assumed in this topic. The equation of a circle is written in the form x minus a squared plus y minus b squared equals r squared, where AB represents the coordinates of the center of the circle and r is the radius. The equation of a circle can also be written in the expanded form, which is the form x squared plus y squared plus 2gx plus 2fy plus c equals 0, and in this case g, f, and c are constants. To get from the expanded form to our normal form, so from here to here, we have to complete the square. We will look at that in example number 1 below. So let's look at some past paper questions on the equation of a circle. Number 1, the equation of a circle with center C is x squared plus y squared minus 8x plus 4y minus 5 equals 0. Part A, find the radius of the circle and coordinates of C. So if we want to find the radius of the circle and the coordinates of the center C, we have to write the equation of the circle in the form x minus a squared plus y minus b squared is equal to r squared. So to do that, put all the terms that have an x next to each other, and the terms in y will also be next to each other. Then if you have any constants, move the constants to the right hand side. So after we do that, it will look something like this. So the terms that have x are the ones in blue, and the terms with y are the ones in green, and the constant is 5, which is on the right hand side. Then you have to complete the square for x squared minus 8x. And if you complete the square, you end up with x minus 4 squared minus 16. Then also complete the square for y squared plus 4y, and you end up with y plus 2 squared minus 4. Then again move all the constants to the right hand side. So that's negative 16 and negative 4. So you end up with x minus 4 squared plus y plus 2 squared is equal to 5 plus 4 plus 16. And if you simplify, you end up with x minus 4 squared plus y plus 2 squared is equal to 25. And now we've written our equation in the form x minus a squared plus y minus b squared is equal to r squared. Then we can read off the coordinates of the center of the circle. So the coordinates of the center of the circle are 4 minus 2. And since r squared is 25, our radius will be square root of 25, which is 5. So our final answer will be C is 4 minus 2 and r is equal to 5. Now let's move on to part B. The point P, 1, 2 lies on the circle. Show that the equation of the tangent to the circle at P is 4y equals 3x plus 5. So here we have a diagram of our problem. So we have the tangent in red and we have our circle in blue. And we're supposed to find the equation of the tangent. So you can tell that the tangent is perpendicular to the line from the center to P. And so we can use the idea m1 times m2 is equal to negative 1 to find the gradient of the tangent. So let's start by finding the gradient of CP. And if you substitute the coordinates of C and P, you get that the gradient of CP is negative 4/3. And if we use M1 times M2 equals negative 1, then the gradient of the tangent is 3/4. And notice that the tangent passes through the point P. So now we have one point, which is P, as well as the gradient M, which in this case is 3/4. So we can now find the equation of the tangent. So we have our gradient and the point that we're going to use. And now we're going to substitute into y equals mx plus c. And if you substitute and if you solve for c, you get c is equal to 5/4. And therefore the equation of our tangent is y equals 3/4 x plus 5/4. But they want you to show that the equation of the tangent can be written as 4y equals 3x plus 5. So make sure you multiply both sides by 4 to get rid of the denominators here, and you end up with 4y equals 3x plus 5, and that is the final answer. Now let's move on to question number 2. The coordinates of 2 points A and B are negative 7, 3, and 5, 11 respectively. The perpendicular bisector of AB has the equation 3x plus 2y equals 11. A circle passes through A and B, and its center lies on the line 12x minus 5y equals 70. Find an equation of the circle. Okay, so as always, let's start by sketching a diagram of our problem, and this is the diagram. So we have our perpendicular bisector drawn in red and our line joining points A and B. Then we also have the line 12x minus 5y equals 70, which passes through the center. So we can tell that the perpendicular bisector and the line 12x minus 5y equals 70 both pass through the center. So that means if we want to find the coordinates of the center, we can solve the equations of these two lines simultaneously. So we solve the two equations simultaneously, and we get x is equal to 5. And if we evaluate y, we get y is equal to negative 2. So the coordinates of the center are 5, negative 2. Now to find the radius, we're going to use the formula for length of a line. So in this case, our radius is from B to the center C. So we substitute the coordinates for B and C into the equation for length of a line, and we get that our radius is 13. And now we can write our equation in the form x minus a squared plus y minus b squared equals r squared. And in this case, a is 5, b is negative 2, and r is 13. And so the final equation becomes x minus 5 squared plus y plus 2 squared is equals to 169. And that's our final answer. Now let's move on to number 3. A circle has center at the point B 5, 1. The point A minus 1 minus 2 lies on the circle. Find the equation of the circle. So let's sketch a diagram of our problem. We have a circle and it has a center at B, and we are told that A lies on the circle. So A would be somewhere here and B is our center. And now they want us to find the equation of the circle. So in this case, we already have the coordinates of the center of the circle. So that means we can write our equation as x minus 5 squared plus y minus 1 squared is equal to r squared. Remember, we're using the coordinates for B since that's the center of the circle. Now we need to find the radius. And from our diagram, we can tell that from B to A, the length of that line would give us the radius. So if we substitute the coordinates for B and A into the equation for length of a line, we should be able to get our radius, and our radius is 3 root 5. We can now say r squared is 3 root 5 squared, which would simplify to give us 45, and therefore the equation of our circle is x minus 5 squared plus y minus 1 squared is equal to 45, and that would be our final answer. Now let's move on to question number 4. A circle with center C has equation x minus 8 squared plus y minus 4 squared is equal to 100. Show that the point T negative 6, 6 is outside the circle. So we're given that a circle with center C has this equation, and that means that its center C has the coordinates 8, 4, and it has a radius of 10. Then they are asking us to prove that the point T negative 6, 6 is outside the circle. So what we can do is to simply substitute the coordinates of T into the equation of our circle, and when we substitute into the equation of the circle, we end up with r squared is equal to 104, and if you simplify to get the radius, you get r is 10.2. So since the radius that we get when we substitute the coordinates of T into the equation of the circle is bigger than the actual radius of the circle, it means that T lies outside of the circle. So if I'm to sketch a diagram, it would look something like this. So we're saying from this point to the circumference, that would be 10. But 10.2 would lie somewhere here, so we'd say T is somewhere there, and as you can tell, T lies outside the circle. So your final answer would be saying that 10.2 is greater than 10, so that means that T lies outside the circle. Now let's move on to part B. Two tangents from T to the circle are drawn. Show that the angle between one of the tangents and CT is exactly 45 degrees. So now let's sketch a diagram of our problem. So we have a circle with center C here, and we have T over here. So the question wants us to show that the angle between one of the tangents, so this is a tangent from T going through B, that's one of the tangents, and CT is exactly 45 degrees. So that's this angle here. Let's call that angle theta. And as you can see, from C to B, our length is 10. And if you calculate the length from C to T using the formula for length of a line, you get 10 root T. And notice how CTB is a right angle triangle, so we can use SOHCAHTOA to find this angle theta. And so we can say that this side CB is our opposite, and the side CT is our hypotenuse, which means that we have opposite and hypotenuse, so we're going to use sine theta is equal to, our opposite is 10 and our hypotenuse is 10 root 2, and theta is equal to arcsine of 10 over 10 root 2, and you get theta is equal to 45 degrees, and therefore you have proved that the angle between one of the tangents and CT is exactly 45 degrees, and this would be your final answer. Now let's move on to part C. The two tangents touch the circle at A and B. Find the equation of the line AB, giving your answer in the form y equals mx plus c. Okay, so let's start by sketching a diagram of our problem. So again, we have our circle with center C, and we have our point T negative 6, 6, and we are told that our two tangents touch the circle at point A and point B, and we are required to find the equation of the line through A and B. So as you can see from the diagram, CT is perpendicular to AB. So to get the gradient of AB, we can use m1 times m2 is equal to negative 1. So let's start by finding the gradient of CT. And if you substitute the coordinates of C and T, you get the gradient of CT is negative 1 over 7. And if you use m1 times m2 equals negative 1, you get the gradient of AB to be 7. And from the diagram, you can also tell that the midpoint of CT lies on the line AB. So we can find the coordinates of the midpoint of CT and use that to help us find the equation of line AB. So we substitute the coordinates of C and T into the formula for midpoint, and we get that the coordinates of the midpoint are 1, 5. Now we can find the equation of line AB. It has a gradient of 7 and it passes through the midpoint of CT, which has coordinates 1, 5. And if you substitute into the form y equals mx plus c, you get c is equal to -2. And so the final answer will be y is equal to 7x minus 2. Now let's move on to part D. Find the x coordinates of A and B. So if we come back to this diagram, you can tell that A and B are the points of intersection between the line through AB, which is this green line, as well as the circle. So if we can solve the circle and the line through AB simultaneously, we should get the coordinates of A and B. So we have the equation of the line through AB and we have the equation of the circle. We substitute 7x minus 2 into the equation of the circle and simplify, you end up here. Then expand the brackets and you should end up with a quadratic, and if you solve the quadratic you get x is 0 and x is 2. So the x coordinates of A and B are x is 0 and x is 2, and that would be our final answer. So that's all for today's video. Thank you for watching. If you want access to this PDF, you can click the link down below in the description. You can also access more of my resources on my website CIE A Level Maths 9709.com. The link is also in the description.